All right, so we're going to be talking about marine pollution, which is chapter 16? No, 14, 14 or 15, one of the two. It's like the second to the last chapter. So on this image here, you can see a pile of floating trash in the ocean, and you can see some fishes that are aggregated underneath this pile of trash, and you can see that this trash is mainly made out of rope. Looks like maybe some fish nets, but it's pretty tangled up in there. So you can see that this might be kind of a hazard for those fish who are hanging out underneath it if they get too close to it. But we'll talk about why that is in a bit. Um, so some sources of marine pollution are marine transportation. So whenever you take a ship somewhere or you take a cruise, um, that ship there is releasing pollution into the ocean, whether it be the sewage that comes out of the boat, or whether it be gas or oil or whatnot, or trash even from that boat. All of that goes into the ocean. Um, there's ocean mining operations, so whenever they drill for oil, that will inevitably cause some sort of pollution in the ocean. So a lot of times oil spills from these oil rigs will happen. Fishing practices, as you can see in that image that I showed you last, those ropes and fishing nets, well, that's all from fishermen basically. So they tend to leave their equipment behind a lot of times. Sewage disposal into the ocean. Here on Earth, I can't think of any place around the world that does not dump their sewage into the ocean. So some places um, will filter through their sewage more so than other places, but we'll talk about that and those impacts to the ocean. Polluted runoff from land. So whenever it storms, a lot of trash or oil can get into that runoff, and then eventually it'll get into the ocean. Use of seawater for human benefits. That's essentially um, to cool down machinery. So some companies will pump in seawater and from the deep ocean where it's colder, and they will run it through their machines to cool down their machines, and then pump the water back out. And when they do that, some chemicals can be transferred into the seawater, and also too that seawater now is heated up. It's no longer at a cool temperature, and so when you pump it back into the ocean, you're adding heat, you're adding chemicals, and therefore it's a source of marine pollution. And then you can have accidental spills of petroleum and other chemicals. So whenever you're shipping oil from place to place or other chemicals, and say an accident happens to that boat, all of that material gets into the water and causes pollution. And then just garbage in general. Our our daily living produces a ton of trash, and more than half of that trash will end up in the ocean at some point in time, whether it's because you were at the beach and you didn't pick up your trash and the wind picked it up and blew it into the ocean, or you were actually good about it and you put it in the trash can, but the wind came by, picked it up, and deposited it into the ocean. So either way, or and then also too, even if the trash gets to the landfill, it could by nature get into the ocean one way or another, whether it's runoff or the wind or by some other means. Okay, so what is marine pollution? Because you saw all those different sources, but they were all over the place. Like there wasn't just one common theme. But essentially, a pollution is any harmful substance. So that's just pollution. And then um, in any given sense, it's really hard to classify or determine the degree of pollution, especially in the ocean, because as you can see in this image right here, you can see all of this trash on this one beach. And while you can probably quantify all of the trash that's on the beach because you can actually see it, In the ocean, it's a little bit harder because you don't know, like you can't just fly over one stretch of ocean and be like, okay, there's, let's just say 75% trash right there, because a lot of it is in the water column. It's below the surface. So you would literally have to send a diver down there to quantify how much. But is that even safe to do? So there's a lot of questions about how do you quantify pollution, especially in the ocean. So how do we try to quantify this? So marine pollution is just any harmful substance that's in the ocean, right? So scientists have kind of sort of come up with a method called an environmental bioassay, which can somewhat determine the concentration limits of pollution. So now keep in mind, this is just an estimated concentration. It's not an exact amount by any means. So if we look at this photo right here, you can see that there's a lot of trash at the surface. So at the surface, they can use equipment to kind of get an idea. They can take photos and just estimate, oh, okay, looking at this photo, it looks like there's 95% pollution at the surface, right? Something like that. But again, it's only an estimate, and these estimates vary depending on who's taking the data. So there really is no hard and fast quantifiable measure to indicate how much trash is in the ocean. That being said, let's talk about these different types of pollution, and maybe that will help you understand why there really is no steadfast way of quantifying pollution in the ocean. So if we talk about petroleum pollution, which is just oil, petroleum is naturally occurring, right? It is a natural product it's a natural byproduct of organic material breaking down and being compressed over time. You eventually get oil. When oil does get into the ocean and it causes pollution, it generally can kill marine animals. So this image right here is that of a pelican who got stuck in an oil spill, and you can see this pelican is just covered head to toe in oil. So there's a number of things that will happen to this pelican. If this pelican does not get help right away, this pelican will either die of hypothermia because that oil has now seeped through all the layers of its feathers. So that water that that pelican is sitting in is penetrating all the way to his skin and causing him to lose heat very rapidly. Additionally, that oil is very heavy. So that oil does not allow that pelican to fly away. So he not only is stuck there, but he's losing heat. He also probably ingested some oil, right? You can see there's some remnants of that oil within his mouth there. Oil has natural toxins in it. So these toxins are PHAs, polyaromatic hydrocarbons, as well as heavy metals. And just the same for humans, they are also toxic for animals as well too. So it's kind of like a multifaceted thing here. This pelican needs help right now if he's going to survive, not only for the ingestion part, but also for his warmth. He's losing all of his warmth. All right. So now, how do we clean up oil spills? So if you look at this image right here, you can see the oil is on top of the sand there. And in this case, it's not an ideal situation, but it would be easier to clean up this oil spill versus if the oil was in the water. Okay, in that previous example, you could see the oil was in the water. And so that makes things a little bit more difficult. But initially, when you're cleaning up oil, the key factor in cleaning up oil spills effectively is time. The sooner you can get to the oil spill, the quicker you can clean it up, because initially oil will float on the surface of the water, right? I mean, we've all done that salad dressing trick where you put some oil and water and they don't mix, but the oil floats on top of the water. And that's exactly what happens here. So the oil will initially float. And so if responders can get to that oil spill quickly enough, they can essentially vacuum up the oil that's floating on the surface. Now, do keep in mind, some of these oil spills happen in very remote areas. So response time is delayed. And so when response time is delayed, you pass this initial stage where oil floats, and over time the sun will degrade that oil to the point where the oil separates. Now, oil is not just one type of material in liquid form. It's made up of different grades of materials. And so that gas that you put into your car, that's separated from what's known as crude oil. Crude oil is made up of different stuff. So the gas that you put in your car is, say, one layer in crude oil. Jet fuel is another layer. Diesel fuel is another layer. So what happens with oil is it's pumped out of the ground. It's sent to a refinery. At the refinery, they process that oil and separate out the different layers. So let's just say diesel will come out first, okay, because that's the most heaviest. Then the plant continues to process that oil, and then gasoline for your car comes out. All right, so they extract all of that. And then if they continue to process that oil, then they get to what's known as jet fuel, which is the highly refined fuel. And that's usually the last byproduct of crude oil. And so you see these different layers popping up. And that happens in nature too. If this oil comes in contact with the sun, it gets heated up, and the conditions become right to the point where it starts separating. And so those heavier layers, like your diesel, once it starts to separate, it will sink in the ocean. And when that happens, that makes cleanup very difficult, because not only do you have stuff that's floating at the surface, but you also have to figure out how do you get the stuff that already sank down at the bottom of the ocean, right? So sometimes, under certain conditions, they can use bioremediation to help clean up spills, and that's essentially using microbes, specialized microbes who actually feed on oil to try to help clean up the oil spill. But this is, again, a slower process and really only works under calm conditions. If the oil spill is out in the open ocean and there's a lot of waves and a lot of wind, bioremediation is not going to be as effective as just straight up vacuuming up the oil. They do have different types of methods for cleaning up oil spills. So you have your bioremediation, you have surface suckers. Basically, they just vacuum up whatever oil is at the surface. They do use floats that go around the oil spill to try to contain it. Or sometimes they just let nature do its thing and hope that not too many organisms die because of that. So there's ways. But the main thing is just to prevent oil spills in the first place. Oil spills are pretty devastating. They release a ton of oil into the ocean environment at one time. So unlike natural seeps of oil that only release little bits of oil at a time, in which microbes can take care of that amount, oil spills release way too much, in which natural processes cannot take care of it. So the best way is just to prevent it completely. And in order to do that, you need to create chips that have double hulls. So essentially, you'll have a ship or a tanker that has two walls on the outside. So just in case the outer wall gets damaged, the inner wall will still remain intact, and it should hopefully maintain the oil that's within the cargo hold so that it doesn't get into the environment. So this is just one solution in which companies have tried to prevent oil spills. Granted, the other alternative to preventing oil spills is just not to use oil. But a lot of the equipment that we use today requires oil. So until we get to that point where we do not require the use of oil, oil spills and shipping of oil will still be a thing. So that was oil. Next, let's talk about sewage. And sewage is a type of chemical pollution in the ocean, because what sewage does is it transports nutrients into the ocean. And nutrients like nitrogen and phosphorus is what algae needs in order to grow more efficiently, because they're not really plants, but they're plant-like, right? So they need nutrients in order to grow and become more abundant. And sewage is an excellent source of those nutrients into the ocean. And for on land, how sewage is treated is it's treated in 3 stages. The first is primary treatment, then you have secondary treatment, and then you have tertiary treatment. And depending on which one your local treatment plant does, will determine what level of nutrients is being introduced into the ocean. So, for example, primary treatment only removes the solids, and so a lot of the liquid waste is still present within the sewage, and so all of that, if primary treatment is deposited into the ocean, then that one still has a lot of nutrients within it. Secondary treatment goes one step further, so it removes solids and it kills some of the bacteria. So basically it has a little bit less nutrient concentration than primary treatment, but it still has some concentration. And then tertiary treatment takes it a step further. So it does remove solids, it does kill some of the bacteria, but it also applies a UV filter and extra filtration, and it removes any excess nutrients from the water. So it's almost to the point where it's gray water. So you can basically use it for agriculture, and you can use it for like golf courses and whatnot, but it's not drinkable at this point. It needs to go a couple more stages further before it becomes drinkable. But you could. And so when you think about the cost of each type of treatment, primary treatment is the cheapest. And then secondary gets a little bit more expensive, and then tertiary is the most expensive out of these 3. But if you were to create drinking water from sewage, that would be the most expensive. And so typically that's not done. A lot of our drinking water comes from aquifers underground. So in this case, then I want to pose a question to you guys. What sort of sewage treatment do we do here in Hawaii? So I'll let you guys think about that. You guys can Google it too. I don't know if you guys will find it on Google, maybe. But if you guys didn't know, okay, just take a random guess. What do you think we should be doing here in Hawaii, and what do you think we are doing here in Hawaii? Because my opinion is we should be doing tertiary treatment, okay? But it may shock you that we are only doing primary treatment here in Hawaii. Yeah, we only remove the solids, and then we pump that sewage straight out into the ocean. So I have a good example a little bit later on about, actually, do I have that example in here? I may not have that example in here, actually. But there's a good example in Kaneohe Bay here in Hawaii, where sewage was pumped directly into the bay back in the 50s and 60s. And what happened was that caused eutrophication, which is an excess of nutrients in the water column, which then caused overgrowth in algae. And so the algae started taking over the coral reefs that are in Kaneohe Bay. And so when they stopped pumping sewage in the, I think it was mid 70s, the environment in Kaneohe Bay is slowly coming back to what it used to be, but it's taking its time. And so now it's been, almost 50 years since the last amount of sewage was pumped into the bay, and it is still in a degraded state. So it definitely did its damage, and it's taking quite a bit of time for it to recover. So that was sewage. Let's talk about some other chemical pollutants that you can find in the ocean, and that's PCBs and DDT. These two particular chemicals are very harmful to the environment. PCBs are a chemical that's used in cooling down transformers. So essentially what transformers do is they take high voltage electricity, they run it through the machinery, and they downgrade the voltage to a voltage that can be used in your household. So that's the primary use for transformers. And because they're converting all of this electricity from one voltage to another, they tend to heat up. They store a lot of heat in them. So in order to keep the machinery cool, they had to develop a chemical that would do that. So PCBs was developed back, I think it was like 40s or 50s probably, to keep the machinery cool and absorb that heat that would otherwise affect the machinery. But the side effect of using PCBs is if it gets into the environment, it can do some huge damage to not only the organisms but as well as humans. If humans were to ingest it, or the marine organisms, it could poison them as well as kill them. DDT is another chemical that is no longer in use today, but it was used as a pesticide so that it would kill all of the mosquitoes during the summertime in California. But what ended up happening was excessive use of DDT in the environment would get into the ocean and get into the fish, and then the birds would eat these fish that were contaminated with DDT. And while it didn't do anything to the fish, what it did to the birds was cause them to have a lack of calcium deposited into their eggs. And so when the mother would sit on top of the eggs, she would inadvertently crush her eggs because they didn't have the strength in the shell needed to withstand the pressure of her sitting on top of them to keep them warm. So you can see that image there. Those are eggs that were crushed because they were too soft and didn't have enough calcium carbonate within them to hold their structure. So while DDT and some other toxins that get into the environment don't have a direct effect usually, they do have a delayed effect on other organisms. And a lot of these toxins linger within the environment as well too. So even though DDT has, we've stopped using DDT, it took a number of years after stopping that in order for the concentrations to get low enough to not affect bird population. So for a while, when you went into, you were at California, there weren't any birds chirping during the summertime when you would expect them to. Ooh. Okay. So that was some other toxins. Now let's talk about mercury poisoning. I think you guys have all heard of the effects of mercury if you eat too much fish. And a good example is the Minamata disease that happened in Japan. In a town called Minamata, and this town lived on the coastline of this bay called Minamata Bay. And along the bay, they also had a chemical plant that the byproduct that they produced was a mercury byproduct. And so it produced methylmercury. And what ended up happening was that mercury they released all of that byproduct into the bay, and it got into the fish. And so essentially what happened was bioaccumulation. So the methylmercury accumulated within the plankton, which were then eaten by the fish, and then larger fish would eat those smaller fish. And it got to a point where the concentration within the fish was pretty high, so that when the humans finally went and ate the fish, they suffered serious health effects, right? So they would have birth defects, brain damage, paralysis, death, and even blindness. So if a mother was pregnant and she was eating this contaminated fish, her baby, when it was born, if it didn't die in the womb, and it was born, it would come out with a whole slew of birth defects. The baby would probably be paralyzed, maybe blind, and it would have brain damage to the point where it couldn't function as an individual. So it was a pretty serious case that happened, and they eventually found out that it was this chemical plant that was introducing all of this mercury into the bay. But mercury is a natural chemical, and the main method of getting mercury into the ocean is by burning of fossil fuels. So I'm sorry, but all of you guys who drove to campus today and tomorrow, you are contributing to the amount of mercury that's in the ocean. Don't worry, don't feel too bad. I drive to campus too, so I'm also contributing. But one way, again, not to sound repetitive or anything, but one way to reduce the amount of mercury within the ocean is to stop burning fossil fuels and to go to cleaner energy. So like electric cars or hydrogen fuel cells. Those would be cleaner alternatives to burning fossil fuels. All right, so you can find this. It's a small little wallet-sized card that you can find at majority of the grocery stores and any place that tries to make you aware of what mercury levels are within fish. But as you can see here, there's 3 different categories. You have your low, medium, and high. And everything within the low category, there's no limit on the amount of fish that you can eat within this category, because the mercury concentrations are very low. All right, so you could eat these types of fish and marine organisms every day of the week and you would be just fine. So some examples are flounder, hake, mackerel, salmon, shrimp, tilapia, trout, right, butterfish. So all of these organisms right here feed directly on the plankton. So when they feed directly on the plankton, they're not getting as much mercury as, say, the larger category in your medium and high, okay? Because they're not actually eating fish, they're eating small plankton. Okay, now do keep in mind some of those fish there in that low category have a red asterisk next to their name. And when you see that red asterisk, that means that that fish is being overfished. So it's probably a good thing if you don't eat those types of organisms. So for instance, if you were to eat wild flounder, this is not your farm-raised flounder now. That would probably not be wise, because that fishery is being overfished at the moment. Or you can see shrimp. shrimp has an asterisk next to it, and that is referring to wild stocks of shrimp. That is not referring to farm raised shrimp. So all the shrimp that you guys see in the stores now is all farm raised. That's the only way that fishery can be sustainable, is by farming it. Same thing with scallop and haddock. Now haddock has the in parentheses Atlantic next to it, which means the Atlantic fishery for haddock is being overfished. But if you were to eat the Pacific haddock, that one is not being overfished, and that one is fine to eat. Okay, so you can see trout. Trout has fresh water next to it, so they're saying that the freshwater trout is fine. But if you were to find saltwater trout, that would not be. I don't know if you can find saltwater trout. Let's see. Now if we go to the medium category, this category, these types of fish tend to eat the low category fish. So they have an increased amount of mercury within them, and you can see a number of them have the red asterisks as well too. So your skipjack tuna, your snapper, skates, cods, but only your Alaskan cod is overfished, and your halibut. But your halibut, only the Atlantic stock is overfished, not the Pacific one. Okay, and then so for medium, you typically would not want to eat these fishes more than a couple times a week in order to keep your mercury levels down. And then the high category, this category, you definitely do not want to be eating these fish more than once a week at the most, because these guys tend to eat the medium and low fish categories. So they'll eat any other fish. So they tend to have a much higher concentration of mercury within their meat. And so some of these, like the marlin, the shark, swordfish, other types of tuna, your sea bass, you can see a lot of these fish in this category are overfished, because they are what you would call the good eating fish, right? And so typically they are sought after. But do keep in mind, fish do have what's known as selenium. All organisms have selenium within them, but fish, unlike marine mammals, have a higher concentration of selenium, and selenium has been shown to counteract mercury. So while these fish, like the grouper and the marlin and the shark, are in the high category, they do have high levels of selenium, which counteracts the mercury. So while it's a good thing not to eat too much of one thing, definitely do not be afraid to eat the fish as long as it's not overfished, right? If that fishery is doing fine and it's sustainable, just moderate, right? Like anything else. Okay, so what is bioaccumulation and biomagnification? So bioaccumulation is the accumulation of a chemical within marine organisms, or just organisms in general. And then biomagnification is that, so when you go up trophic levels, you have an increase in that toxin. So in the image on the left hand side there, you can see methylmercury is created by burning coal or even from volcanoes. And then that methylmercury gets into the ocean, and gets into the krill population. And so at the krill population, you can eat as much krill as you want, although typically we don't tend to eat a lot of krill right now. And then salmon and other organisms like pollock and oysters will eat those krill. And so those two categories right there, the plankton and the small fishes, there's no limit to the amount of fish that you can eat within that category, because the concentration of mercury is low. And then once you get into your trout and your canned tuna, those probably should not be eaten more than a few times a week because that concentration is starting to increase. And definitely once you get to the halibut and the albacore tuna, you definitely do not want to be eating that more than a few times a month because that mercury concentration is so high. So if you look at the image on the right hand side there, if you start at the bottom, that's where your krill would be at. So you can see the dots in the boxes represent the concentration of mercury. And so down at the bottom, there's not a whole lot of mercury concentration. But as you go up each level, so say the krill is eaten by the plankton, and the plankton gets a little bit more mercury, but it's still not that bad. That small fish there in the third row eats the plankton, and he gets a little bit more mercury now, but still it's at a manageable level. Then that larger fish there eats the smaller fish, and that mercury concentration starts to get up there a little bit. And then finally that eagle is eating that big fish, and so that eagle there, if we were to eat the eagle, would have a huge amount of mercury within itself, and it would actually be very toxic to eat that bird. All right, so hopefully you guys understand that. So you can see there's a doubling effect of that mercury each time it goes up a level. So whereas at the bottom you only started with 2 dots, by the time you got up to the eagle, you're at what is that? 2, 4, 6, 8, 10, 12. You're at 12 dots now. So that's 6 times the amount, right? Of what you started at. Which, when you look at mercury and toxins, that can be a huge effect. All right, so that was toxins within the ocean. Next, you have non-point source pollutions. And so unlike point source pollutions, which you know where the source of pollution is coming from. So for the example, the mercury example, where that chemical plant in Minamata, Japan, was dumping all of their chemical into the bay, that would be a point source because you know where that chemical is coming from. It's coming from that plant. A non-point source pollution is one that you don't know where the pollution is coming from. So it can be any type of pollution entering the ocean, and it could have multiple sources. So for instance, if we see this, the image there, and it's an image of oil. You know, the cars are parked on the side of the road. You've got some oil leaking from one of them, and you've got some trash over there. And so if that oil and the trash were to make it into the ocean, that would be considered non-point source because you don't know where that oil started from. It could, let's just say it started from that black car that's in that image, right? And let's say in the next few minutes that black car leaves, but the oil doesn't leave with the car. The oil stays there. So that oil, the next time it rains, that oil is going to get washed into the storm drain, and then it's eventually going to make its way into the ocean. And even though the black car is not there anymore, we know that the oil came from the black car, but once the oil gets into the ocean, we don't know where it originated from, right? And you could have multiple sources of this oil coming from all different sorts of cars around the city. So if you can imagine all the cars leaking just a little bit of oil while they're sitting there, and all of that oil gets into the ocean, well, now we just polluted the nearby ocean, right? And same thing with that trash. If we have a big rainstorm and that trash gets swept up and goes into the ocean, we don't know exactly where it came from, right? Looks like there's a water bottle and maybe a paper plate. Well, where did that paper plate originate from? I'm sure it didn't originate from the sidewalk right there. Pretty sure maybe a nearby restaurant, that's where it originated from. But we don't know, right? It's not like that paper plate has the name of the restaurant where it came from on that paper plate, right? So generally, possible sources of non-point source pollutions will be storm runoff, illegal dumping, and the wind as well too, right? Okay, so now we get to plastics. Plastics is the #1 source of pollution into the ocean. And typically, because plastics float, that tends to aggregate at the surface, but not always. And just under 80% of the marine pollution in the ocean is land-based, and it is plastic. So you have majority of that pollution being plastic. Okay. And plastic does not readily break down. It is not biodegradable. They do have some plastics that are biodegradable, or at least they're labeled as biodegradable, but really they're not. Okay, they still break down into small pieces, and by the time they get to those small pieces, they do not break down any further and contribute to what's known as microplastics. Typically, plastics will tend to strangle or even kill marine organisms. So in that image right there on the left-hand side, you can see a turtle. Turtles are known for eating jellyfish, but you can see that plastic bag there, kind of, when it's in the ocean, kind of tends to look like the jellyfish. So that turtle will tend to eat that plastic bag thinking it's a jellyfish. And when it eats that plastic bag, it won't get any nutrients from the plastic bag, and it won't pass through their gut. So it'll stay within their stomach forever, basically, and continue to trick that turtle into thinking that it's still hungry. So I didn't put some gruesome images, but there's a lot of images of seabirds that have died this way, where they've just eaten so much plastic that they thought they were full, but in reality they were still hungry and they were starving to death. All right. So if you are interested, you can go and Google it, but I did not put any photos on here of that because it's very disturbing. Okay. But essentially, what you should know is it is illegal to dump plastic in the ocean, no matter where you are in the ocean. So don't go dumping plastic into the ocean. Okay. So microplastics and nurdles. So once plastic in the ocean degrades to the point where it is less than 5 millimeters in size, it is considered a microplastic, because at that point the plastic no longer breaks down into small pieces. All right, it no longer breaks down anymore. It just kind of stays at that point. Previously, a lot of facial products and cleaning products used these tiny little beads, which is an image on the right-hand side there. They can be found in like facial scrubbers and toothpaste, and they were used as abrasives. But they're so tiny that they don't break down within the environment. So they contribute to the plastic pollution within the ocean. Nurdles are plastic pellets in which plastic items are created. So they are the beginnings of plastic, and they are in small little round balls, and they are shipped around the world. And if something happens to that shipment while it's over the ocean, and all of those nurdles get into the ocean, well, you just dumped a whole bunch of microplastics into the ocean, right? And a lot of these microplastics are brightly colored. So a lot of the marine organisms eat these microplastics thinking it's food, when really it's nothing more than just plastic and not very nutritious at all. So in the ocean, there are some areas where we have very large patches of garbage, and these are more familiar to you as the Great Garbage Patch of the Pacific. And in the Pacific Ocean, we have two large garbage patches, one on the east side, one on the west side. The one most of you guys should know about is the one on the eastern side, which is kind of northeast of us. And because of the ocean gyres, it basically has created its own mini gyre of trash on both sides. And so as that gyre is rotating in a clockwise direction, it is causing that trash to accumulate within this area and also kind of create its own little gyre of trash. Okay. Trash will circulate around this dryer, may end up getting caught within this garbage patch, and definitely all the different countries that trash either runs off into the ocean will eventually get into one of these garbage patches. So on the next slide here, this is an image of one of the garbage patches, and this is just below the surface, as you can see, and this trash right here is pretty bad. So this is just a surface shot right underneath the surface, and as you can see, there's a whole bunch of rope entangled. There's some nets. I don't really see too much else, but you can see a lot of fish within this image here. So as you can see, this might be actually a very dangerous situation for these fish if they were to get caught in those nets. And if they do get caught within those nets, that's what's known as ghost fishing, because these nets are still catching fish, but nobody's consuming those fish. Okay, so that's another problem with all of this plastic and garbage within the ocean. It's not only polluting the ocean, but it's also depleting our marine resources, and we don't even know about it. We're not even using it. Okay, and so this trash right here can go pretty deep. I don't know exactly how deep the garbage patch goes. I'm not quite sure if anybody actually knows, but it can go pretty deep. And on this slide right here, this is just a aerial view, so looking down at the surface of the ocean on the garbage patch, and as you can see, it's terrible. At the surface, you can just see all of this trash floating around, and it's not only creating pollution, but it's also accumulating bacteria and viruses. So you're not only introducing toxins into the ocean, but you're increasing that microbial concentration within the ocean, which could be bad, depending on what microbes are growing. One way to reduce trash that goes into the ocean is limit the amount of single-use plastics. So that's, for example, straws or paper plates, takeout plates. You guys should all be familiar with this from the Zero Waste Audit now. Disposable utensils. Those salmon fillets of salmon that you get from Costco, they all come individually wrapped. Well, that's all single-use plastic. So if we try to limit the amount of that we use, hopefully that can reduce the amount of trash that gets into the ocean. If we recycle plastic, that's one way too. The image on the bottom here shows the different types of plastic, so you can see they range from 1 all the way to 7. And here in Hawaii, we typically only recycle 1 and 2. 3 through 7 is just thrown away in our landfill. And even 1 and 2, sometimes it's not recycled here in Hawaii because everything here in Hawaii, we don't have a recycling plant to recycle plastic. Everything is shipped to the mainland or other countries. So if those other countries or the mainland does not want our plastic, then it gets burned. So that's kind of just a caveat here in Hawaii. But technically speaking, if you go to the city and county's refuse website, which is Opala, OPALA.org, or no, I think it's gov, actually. If you go to their website, they do say that they do recycle 1 and 2. So, that being said, if you properly dispose of plastic, so you don't just litter or leave it on the ground or whatnot, if you properly put it into a trash receptacle, that's one way of reducing trash that gets into the ocean. And if you pick up any trash that you see at the beach or on land, that would definitely help, because typically speaking, that trash will end up in the ocean at some point in time, whether it's by runoff or by the wind. Okay. And then the last question I want to pose to you is, who owns the ocean? Because in this sense, this trash problem, this is a global issue, all right? It's not just, oh, what can Hawaii do or what can the US do? It's what can we all do to fix this problem, because we're all contributing to the amount of trash that's within the ocean. So who is responsible for cleaning up all that trash? Because you saw the garbage patches that we have in the Pacific. Who's responsible? Is the US responsible for picking up that eastern garbage patch because we're the ones most responsible for contributing trash there? Or is Japan responsible for the one that's on the western side, right? If you look at this map here, this map shows the jurisdiction of the US. So everywhere that we have either a territory or a state or some sort of coastline that we own, we have a 3-mile jurisdiction off of that coastline. So anything that we say can go on within this 3 miles, yeah, we are responsible for. We are responsible for the trash. We are responsible for the resources within that area. And no other country can come into our jurisdiction and say, oh, you need to do this, blah, 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 okay? But, and so each country has this 3-mile jurisdiction, but there's a lot of the ocean that is not under a country's jurisdiction. So, again, I ask the question, who is responsible? And this is why I say we are all responsible, because in the end, we were all responsible for putting the trash into the ocean. Even though you may not have thrown that bottle of water into the ocean, you may have actually thrown it in the trash can, but somehow that trash ended up into the ocean. So in an indirect way, you are responsible. And I'm not saying you as in you personally. I'm just saying us as a human species. We are all responsible. I am just as guilty, all right? I throw away plastics all the time. I'm terrible at recycling, those Ziploc bags. Oh, I know some people are really good about washing them out and reusing them and whatnot. I am terrible when it comes to that. Anyways, that being said, do your part. Try to help recycle. Try to pick up any trash that you see on the ground. And any small little bit helps, even though it may not. It may not seem like it at the time, but definitely it does help. So that is marine pollution. I think it's chapter 14 or 15. Right. So stay tuned. This was the second to the last lecture. So next week is our last lecture material slides that I will be posting. And next week it will be on climate change. So stay tuned.